In the next section, we're going to talk about the equilibrium constant. And the constant is going to be a big key for us to look into whether a reaction proceeds more forward or more reverse. So whether we have more reactants or products. So the ratio of concentrations is called an equilibrium constant expression. And we're going to look at the ratio of the products, or the concentration of the products, divided by the concentration of the reactants. And we're also, I want to point out that we need to raise these, or we should say raised to the power of their coefficients. Okay, so for the problem that we have right here, and we're going to be looking into a bunch of different equilibriums. So K is going to be our equilibrium constant. There's going to be something called the Kc, which we're using C standing for concentrations, of products divided by reactants. So for this particular reaction, we're going to take our concentration of C raised to the C power times the concentration of D raised to the D power divided by the concentration of A to the A power times the concentration of B to the B power. So this is going to be our equilibrium expression, and here we have the ratio of the products divided by the concentrations of the reactants. So Kc depends only on the particular reaction and the temperature. It does not depend on initial concentrations. Okay, so if you kind of think about this, and we considered this to be kind of a well, if we were going to place a ball here, we could place the ball here, or we could place it here. It doesn't matter where we initially place this ball, because at equilibrium, it's going to end up down here. So here's our initial conditions, and here's our equilibrium condition. That ball or that marble will end up right at the very bottom of that particular well. So if we were going to express this Kc constant for a couple example reactions, consider 2NO gas plus O2 gas in equilibrium with 2NO2 gas. If we were going to write the Kc expression for this particular equilibrium, we would do the concentration of the products, which is NO2, raised to their coefficients, divided by the concentration of the reactants, also raised to their coefficients. So this would be, Kc would equal the concentration of NO2 squared divided by the concentration of NO squared times the concentration of O2. We could also do this for another reaction. For example, 4NH3 plus 7O2 in equilibrium with 4NO2 plus 6H2O. If we were going to write the Kc expression for this, we would take the concentration of the products, which would be NO2 to the 4th power, times H2O to the 6th power, divided by the concentration of NH3 to the 4th power times the concentration of O2 raised to the 7th power. So knowing how to set up an equilibrium expression is going to be very, very, very important as we move forward in trying to do particular problems. So make sure you have a really strong foundation of your equilibrium expression and knowing how to set them up.